Okay, as some of you asked me to do like a proper overclocking guide even for just air or water cooling, so I will be doing that now. So let's just test how easy it is to overclock the RTX 3090 Kingpin with just the standard AIO cooler. So the good thing about the Kingpin model, and it's been the same situation for many generations now, since the beginning of these models, is that you don't have to do any soldering. So the only thing you need in order to overclock this card like properly, even on the stock AIO cooler, is that you need a custom BIOS that increases the power range on the card. I'm sure you are familiar with the shunt resistor modifications. That's very common among new generation NVIDIA graphics cards since like the launch of GTX 680, something like this. So if you just try to do any kind of serious overclocking with the standard BIOS, the card will power throttle immediately if you touch the GPU voltage at all. So the overclocking is heavily limited on modern NVIDIA graphics cards. So you need a custom BIOS, and I recommend you flash the custom BIOS onto the OC position on the switch or onto the LN2. Currently I've set the LN2 BIOS switch, which is on the left. So the right one is normal, middle one OC, left one LN2. So you can do whatever you wish. I'm going to use the same BIOS I used for the records. Now of course, if you have the card in its default form, you don't have to apply these fans like I did. So the cooler is already very good on its own, so the fan will circulate air throughout the whole card, and the airflow will cover both of these heatsinks over here. But since I don't have the original shroud, I've put this 120mm Delta fan onto the big heatsink, and this very standard Alpha Cool 120mm fan onto the smaller heatsink. SR3 Dark and the 28 core Xeon. So the platform doesn't really matter for this purpose. I will use the same operating system I used for the 3090 records, so Port Royal and Firestrike Ultra. But yeah, so these are the steps you have to do. You don't have to do any soldering. For example, on the Asus Strix, you need to solder the external tool by Elmo Labs onto the card, and you can then use that device to control the graphics card. So currently, looking at the offerings on the market, the 3090 Kingpin is definitely the easiest one to set up and just use for like really high scores. So just saying. But yeah, so without further ado, let's get going. Okay, I'm just about to finish a Port Royal score with everything at stock, just out of interest. So I'm running the radiator of the AIO cooler on top of this small CD box over here. It's obviously not the most suitable way to mount a cooler, but it will work just fine for this purpose. And the Delta fan isn't actually that loud, which is a nice thing for this purpose. It's connected straight to 12 volts. That blue fan over there is connected just to it's connected to a motherboard 4-pin fan header. The GPU die temperatures went up to 50 degrees, and the reason for that is that we still have to control the speed of these radiator fans, and I think as well as the AIO pump with Precision X1. So they are not running at full speed on by default. So we still have to control those, and you can also control the separate fan if you attach any onto the separate 4-pin fan connector on the graphics card. Now the LGA 3647 platform is not the most ideal platform for Port Royal, so the score will be lower than what you can get on compared to mainstream Intel platform, for example, or even AMD platform. But mainstream Intel is still the fastest platform for Port Royal, and that's why we use it, like 10900K at 5.4 GHz, 5.5 GHz. But this is the reference score I made, 14,003 points. And if we look, of course I will swap to capture card. So max GPU was 2040, max GPU 1050, spot on. Board max power 444.6 watts, and I don't think that high VRM. It was GPU 2 temperature quite high, 59.51 on MEMS, 59.51, 47 on MEMS. and VRM 50. Yeah, so quite good, I think. So let's get going and let's see how we can actually overclock this card. Okay, so you don't need that many software in order to test the 3090 Kingpin for overclocking. I like to use Pro Royal, but you can use other tests as well, like TimeSpy, 5-Strike Ultra, 5-Strike Extreme, Unigine, Superposition, whatever you wish. So you definitely need GPU Z, so to read all of the information about the graphics card, like temperatures, clocks, temperatures of VRMs, MEMS, and so on. You need the custom BIOS, which I've already flashed over here, onto the OC position or on the LN2 position on the BIOS switch. And then we need the Classified.exe to set all the voltages. And then we need Precision X1 for overclocking. So I first try, or I start in Precision X1. So let's we have to max out the fan. Well, it really depends on how you run the card. I don't have the standard fan connected as I already showed you, but I want to have max speed on the radiator fans and as well as on the pump. So we will hit that. The power is already set to the max on this BIOS, so we don't have GPU temp control at all. And yeah, then what we will do is that we can actually start in Classified.exe, and I will explain the voltages and what are like good ranges on the voltage. So here's how the classified controller looks like. So we want to untick auto. You can also sync if you have multiple of these cards connected, like 2 in SLI, but I assume most of you will be running just one. NVIDIA is the GPU voltage, and I would not go above 1.25 on ambient cooling. The standard or the stock voltage under load is somewhere around like 1.11, 1.12. So we can start maybe, let's say, 1.2. Memory, you also don't have to really touch on ambient cooling. You can, I mean, memory voltage doesn't really help that much on this generation when it comes to memory overclocking. MSVDD is the efficiency voltage, as I explained. You need to increase this in order to have correct performance with overclocked settings. If we leave this at very low value, the numbers will be good, like the clock speeds will be high, they look nice, but the performance isn't as good as we hoped it would be. So we have to increase this to, let's say, like 1.05 to 1.10. On LN2, good voltage is like 1.2. I will set 1.05 for starters. NV frequency, this is the switching frequency for the GPU. We can set this to 700 kilohertz, 800 kilohertz, something like this. And MS freak is the switching frequency for the MSVDD. So we can set like 700 kilohertz. Now, load line is very important on this generation because most of the load line settings will overshoot the set voltage value. So it's good to set relatively low value and do not ever use the highest options on this generation, because if you run the card on LN2, for example, and you have level 1 or level 0 applied and you set, let's say, 1.45, the voltage under load will be like 1.55, and it can even shut down the whole card as a safety feature. So it's best to stick with relatively low load line values. I think we could even try to read the voltage under load to show you guys. So level 6, like level 5, level 6 is a very good value on AIO and also on LN2. Even this will be higher than what we set under load. You can keep the OCPs enabled just as a precaution when running on ambient cooling. These only have to be set to disabled when you run the card on LN2, and that's kinda realistic anyways. So 1.2 stock on memory, 1.05 on MSVDD, 800, 700. And we applied. We can close that. And then GPU temperature is quite nice at the moment. What if you don't know how the card runs or what clocks it will have under full 3D load, you can tick the boost lock feature and it will lock the clocks to the PO state, so the 3D state. So now we have 2085, but of course it will be a bit lower under real load. So what we can do is we can, for example, let's set 1600 on the memory and maybe 150. So 2235 and 1420 on the memory. I might actually put even higher, right? 1700 on the MEMS and 170 on the GPU. Max speeds on the fans and on the AIO pump. So let's try to run these settings. You can read now, we haven't touched the voltage at all on Precision X1, but we can already read 1245 millivolts. So we can see that it's already increased from the real default value. So we can minimize this, go back to Port Royal and try to run. Now I need to find where's my Probit connector header to read the real value under load, because it will be higher than what we set. Actually, before starting, I remembered I'm a bit stupid, so you can go to hardware monitor panel and, oh, actually, where is it? No, I was wrong. So click the left arrow key over here, select monitoring, not animation, if you don't want those stupid texts and images. And we go to GPU NVIDD, so we can monitor both the GPU voltage as well as the GPU die temperature. So you don't need a multimeter, but of course real multimeter reading will be more accurate than the value you can see on the OLED display, but this is already very accurate. So apply, and I will run again. So currently it's reading 1.248, 1.255, and I can show you to you how it looks like while the test is running. Okay, so now it started to test. 65 FPS, 64, and you can see 1.33, 1.34. Of course, it's jumping quite a lot all over the place. So 43 degrees at the moment on the GPU die, 1.33. Maybe the real value is like 1.325, 1.33. So it is much higher than what we set in the software. So even level 6 load line calibration setting on the GPU voltage is already giving like 75 to 80 millivolt overshoot. So just keep this in mind, or bear this in mind when you use the software to overvolt the graphics card. But yeah, our temperature is still below what we had by default, because we set the pump speed and the radiator fans to 100%. So 46.6. I think it should remain, it shouldn't exceed 50 degrees. And once this passes, we can go even higher and see how well it will run. I think the real clock is something like 2210, maybe something around 2200, maybe touch above 2200 under full load, because it drops a little bit from the boost clock values. 65, 66, 67 FPS, 2190 to 2220, 49 degrees, 50 degrees, 15227. Memory clock was completely fine at 1431 without any touch on the memory voltage. Max power 568 watts from the start, so like 120 watts more than what it draw at default. And mem temps 62, it's actually quite warm. 57, 47. Maybe the contact on the memory plate isn't the best possible, so best not to touch the memory voltage for now. 51, 41, 47, 29, 33. I think, if I'm not completely mistaken, these three should be the right side VRMs and these two the left side VRMs. Could be, but I'm not fully sure. So yeah, let's keep going. I definitely want to get some more on the GPU. So let's put 200. See how it says. No, 190, 200. And the GPU boost is sometimes a little bit weird. You don't always know what it's going to set. But now it should be higher. And we can even try 1800 on the memory. So now it should be 14444 on the memory. Maybe 2235 under load. So let's see if it runs. Okay, now I think this is probably the max GPU wise. So the GPU clock under the load was like 2220, 2235, sometimes peaked 2250. But the but the GPU voltage was already quite high, so close to 1.25 set. But under load, it's doing, it's jumping between 1.33 to 1.38. So I wouldn't. I mean, if you really want to overvolt for daily use, I wouldn't go above 1.2 because it scales really well until 1.2 volts. Then the scaling becomes really bad because of the temperatures. So just saying. Now we can maybe, I will just quickly save this out of interest and try a little bit more. So now it was 205, maybe it's definitely, there's no much headroom left because 2280 is instant failure under load in the Pole Royal. So it's definitely not worth it to push it more, and I don't want to increase the GPU voltage anymore. I'll try this and then I'll try to show you the difference between the OLED display voltage readout compared to a real multimeter readout. Now this is definitely a good run. So the clock, the GPU clock under load was 2250, 2235, 2265. The issue is that it actually changes the clock a little bit during the run. So for example, when the ship is about to land, when the camera is on top of the ship, like looking down, in that phase it usually increases the clock a little bit, like 50 megahertz, and it's easy to crash in that phase. But yeah, so maybe like 2250 average clock, and I think it's very good. Max temp was 51, quite warm, so that's definitely the issue here. And where's the board power draw max was close to 600 watts. Damn. Memory, I actually increased the fan speed for this run, so the blue fan on the left is at max speed, as well as the Scythe Ultracast fan that I have blowing over the motherboard VRM area, and also at the back side of the card it is at 100% as well now. 58, 49, 47, then VRMs are 52, 43, 44. Now these are on the issue definitely. 30, 37. So with a mainstream CPU with relatively nice CPU clock, I think this score had been like 15,800, 15,700, 15,800. I think 15,800 because the difference is quite high between these two platforms. The 28-core Xeon platform is not very good for this test. And for the voltages, yeah. And now definitely don't go any higher than 1.25. The actual increment between different load line levels is very, very minor. It could be just a few millivolts, the difference between level 6 and level 5. So we are talking about like 100 millivolt overshoot in many cases. So do not go too high on the voltage, and you can easily use relatively easy low line setting. So let's try a little bit more to maybe 215. Memory is at the max. 1800 was giving issues like colorful artifacts, something like that. 215 now. Okay, so now I'm in the loading screen. 1.257 NVIDIA measured by multimeter, and 1.28 something by the OLED display. And when the load starts, it should ramp up. Remember, OLED display was 1.34 to 1.4, so jumping all over the place, and multimeter is reading around spot on 1.3 volts with load line calibration level 6. So around 50 millivolt overshoot, it's not that bad, but the OLED display is definitely not that good. Jumping all over the place between 1.32 to 1.41 volts. Maybe the OLED display is measuring directly at the VRM and the multimeter from the die itself, because this is definitely a lot more stable value. So those are the voltage measurement differences. Okay, now this is definitely the max. So 1.3 volts measured under load with a multimeter, as we checked, and the clock under load was 2235 to 2265, something like this. 1431 on the MEMS, max temp 50, and board power draw max was 600 watts. Don't know what's this. GPU 2, it's sometimes very high. 60, it's very high. 57, 50, 47, 52, 52, 43, 45 on the first 3 of the VRM temperature measurements, and last 2 VRMs were 30 and 37. Score very nice one, 15,419 with stock 28 core Xeon and without any operating system tweaks. So could be close to 16,000 if I used a 10900K at 5.5 gigahertz. So I think now what we could do is that I could try max on the memory, and I might drop the GPU down a little bit to play it safe, because I want to be sure that if it crashes, it's the memory. So let's try 1850 on the MEMS. Now this is obviously very clumsy way to overclock on if you want to do like an overclock profile for daily use. When it's not written in the BIOS, it's a little bit clumsy, because every time you start the machine, if it has been shut down, you have to reapply the settings, like the voltage settings and the clocks. So that's very clumsy way to overclock. I haven't done like BIOS level overclocking on graphics cards that much, so I cannot give you the ways to do it for now, but I can investigate that for later. So let's try now. 1450 on the MEMS. Is still stable. GPU clock should be around 2200 under load, but we will see. At least the memory did very nice when the card was running on LN2 without any memory voltage setting, like plus 1800, even more, but we'll see. 1450 is already an insane memory clock for an RTX 3090 if it's stable, and not to even mention without any voltage adjustment. So I think it should pass. 1450 on the memories. Yep. 2220 on the core. 2205, 2220 on the core. 1450 on the MEMS. And score is 15,104. So as you can see, on this generation, the memory doesn't really give that much benefit if you try to overclock it. The core is the king with this generation. That's why it's the most important to get the core as high as possible, no matter if you are doing overclocking on air, water, on LN2. So when I was running the card on LN2, it's most important to get the core as high as possible. The best I did was 2760 in Port Royal, 2775 was passing. I think the maximum is somewhere up there. I need to try properly with backplate and Inferno, see if I could get close to 2800. I'm not fully sure what's the required clock for 19,000 points in Port Royal, but yeah, definitely awesome. And memory does help, of course, but the gains are very minimal from the memory. So sometimes memory might come down when you run the card on cold, especially if you don't have any heater plate. Then you might think the core is crashing, but it might actually be the memory. So don't go straight for the max memory clock on LN2. Like if 1450 was the max for me now on AIO, I would leave the memory at like 1420 on LN2 for starters. So yeah, these are the steps, and you can find all the needed things like Classified.exe, information about the BIOS and so on. They should be on the EVGA OC Lab forums at evga.com forums website. So I think this should be like a good guide for you. Don't go higher than this on the GPU voltage. Memory doesn't really need touch at all on AIO. MSVDD 1.05 to 1.1 volts. And yeah, you can obviously max out the switching frequencies for the VRM, but it will mean that the VRM temps will be higher. But raising the switching frequency of the VRM is technically overclocking the VRM, so it will make the VRM a little bit faster in terms of response time, but it will increase the VRM temperatures a little bit. So yeah, if you like to see this real ambient cooling overclocking guide for the RTX 3090 Kingpin, then definitely give me a thumbs up and subscribe to my channel. And thanks for watching one of my videos once again, and I will see you on the next one.